Okay? Need any other parts? Don't think so. Okay. Well, your best bet for making the rotating base is, again, to use hydraulics, and I can kind of show you the basic idea here to give you an idea. Let me see if I can bring up my computer here. Let's see here. Not knowing what your design looks like. Oh shoot. What is this thing doing? I don't know what my thing's doing here on this end. Hold on a second. Let's try hide. There we go. Hide. There we go. What's going on? Why did it do that? Okay, so I don't want to do that. I'm sorry, I'm having trouble with my system on this end. I don't know what it's doing. Let's cancel that.
Well, I had some trouble with the rotating base too, but I think I worked something out. The only issue is that I have to tape it down so that it doesn't move.
I can't switch to my computer, and I don't know why. I pushed the wrong button somewhere. There's like 9 buttons I have to push. I can only select stuff on your end. I don't want to select your input, I want to select my input. Let's whatever. Okay, fine, whatever. What the heck did it just do? Are you guys still there? Oh, goodness gracious. Okay. I have to turn this off. Hold on a second. Something's wrong with my system on this end. Oh, give me a break. Really? Oh, gracious, now what do I do? Alright, let's try this again. Okay, we're back and connected again. Hopefully this will work this time. I don't know what went wrong with the first connection we had. Okay, so now, going back to your concern with making this thing rotate. Let's talk about that a little bit. It probably is one of the more challenging parts of this project. probably the best way to show you this is to just show you two different implementations of this idea. So here on this first worksheet that I gave you guys, it shows a rotating base. You kind of have to zoom in on it to kind of see how this is working. This one looks a little more complicated, but it's actually a bit, it's probably a little more simple than the other one. You can see right here on this left-hand side next to the red syringe, hopefully you can see that, there is an axis. It's essentially just a dowel going through two parts of this platform that all the rest of the arm is built on. And that's a really good way to build a very simple rotating arm, is to just have a platform, and it's not going to look like this one, because remember yours is your own design, but you're going to have some kind of something that your arm is on at the base of it, and that can be your rotation platform essentially. But it's going to need to have an axis, and on this one they actually put the axis on one corner of the platform, and then they connect off of that axis and connected to the side of the platform here. They connect this this cylinder, right? This one of these syringes, right? The red syringe. And again, they have a few parts that we're not using, because I want you to not just put it together. I want you to design things, which means you're going to have to figure out how to fit things in and how to make things work. But in the end, it's going to be the same kind of thing. You're going to have the axis at one part of the platform and have the connection to a hydraulic syringe or a hydraulic piston some distance away from that axis so that it can actually push it. The further it is away from the axis, the less you'll be able to rotate the platform. However, it'll be easier to rotate the platform the further it is from the axis. So you're kind of out of a balance. In this particular picture, looks like it's maybe 1 or 2 inches away from the axis. The piston is connected 1 or 2 inches away from the axis on the platform. And then the platform just slides along this base. If you're going to have a sliding platform along your base, then at least one part of those is going to want to be made of plastic, and the other one probably of wood. Wood and plastic will slide over each other very easily, and you won't have the problem of it sticking to each other. Two pieces of wood have a tendency to stick to each other really well. So that's one way you can do it. Now the other way that you can do it, and there are actually more than just 2 ways, there's lots of different ways, but here is another way. Let me see if I can find this quickly here for you. The other way is to do it in the way they do it, kind of the way they do it in the advanced arm guide here, which and in this one, you can see that they build a different type of platform and put a different type of axis on it, but it's essentially the same idea in the end. Let's see if we can find a picture of it that shows it's turning. So here it kind of shows it fairly well. Here is the axis down between these two plates on the left-hand side. You can barely see it towards the back of these two plates. And then over here they have where they're going to mount this syringe, and the syringe will push on the side of this thing. They also put a stop on it so that it can only rotate so far. That prevents it from going too far, and then they're going to connect this thing over here. Again, they have parts that we're not working with, but you should be able to work it out. Now here you can see, actually, in more detail. Oops. Let's see if I can slide this over. Why can't I slide this over? My screen is funky from the computer. Here we go. So, there we go. So here you can kind of see here that the axis is on the back end of this thing, the back end of these vertically standing plastic sheets or whatever they are, and then off axis, which is closer to the front, they have this blue syringe connected to do the rotating, right, to push it around. And this is a push-pull, this is a push or a pull hydraulic here, so it will turn it both ways. It will turn it away from it or towards it, depending on how you do the controls. So that's another way that you can do it. You have other parts in your kit, like the wheels that may be used for your car, or gears that you could take advantage of, pulleys. I mean, you have all kinds of ways that you could possibly do it. But these two ways are probably your simplest ways to do it, is to connect the platform that your arm is on to some kind of axis so that it can rotate or spin around that axis. And that axis should be probably fairly close to one end or the other of your platform. And then just a couple inches away from that, at most, you put a hydraulic push-pull syringe, and that connects to it to actually do the rotation. Does that explain things on how to do that the simplest way for you? Does that clear things up a little bit? Any particular questions or concerns about that? Okay. So, are there any? Now, did you guys get the materials that I sent you? That's my other question I have for you. You have them all? Okay. Good. I think that we have people out in. Oh, I can't remember the other place we have students at, but anyway, your materials will be coming soon. They should get to you hopefully today or tomorrow, or the latest Wednesday. But they are in the mail, and so everybody should have at least the materials in the mail if you haven't received them yet. And your task is to get that done. I'd like to see video of this thing working. I would like to see your logbooks. I'd like to see lots of pictures and drawings in your logbooks showing you how you did this. And this is essentially all we're doing here this week. And when we come back after Thanksgiving, we're going to start a unit on three-dimensional drawing. And we'll be doing some CAD practice. And maybe even get into some 3D printing of your project. So that'll be our last couple of weeks in this class, and then we're done with Engineering 1000. Anybody else have any other questions before we done today? So we have our finals week here the week before Christmas. I think finals end on the 19th, I think. Let's check that really quick for sure, because I do have that on. I think I have that on the syllabus. Let's check. So last day of class officially is the 20th, and so that's our finals week. So we don't have any class during finals week. But I will probably be having you do one more presentation or something similar for the last project. I haven't exactly decided how to do the three-dimensional drawing portion of this class, since I've not done this in a class before. This is kind of new. But we have CAD design for a week, and then 3D printing for a week, essentially. Those two things are connected to each other, so you'll be designing something on a computer, and then we'll be converting to the correct format and printing it here at the school, and then you'll be receiving that print in the mail. But from that project, we're going to have some kind of final test to put into the gradebook, and I'm still trying to decide what that test will be like. So by the time we get back from Thanksgiving, I'll have that all worked out, and we'll know what we're doing. But the last day of actual class is the 13th. You can see here on the schedule, and then we have a week of finals where we will not We will not necessarily meet, but you may do a presentation and send that in to me. Make sense? Okay. Well, get to work finishing up your project. Make sure you're making good videos and good notes in your logbook, and get those things into me. You can wait and do them over Thanksgiving, but like I said, if you're a football fan or you're a turkey fan or whatever it is you want to do over this break, I would get it done early and enjoy your break. So it's up to you. And we'll see you guys in a week from today.